Hello friends, in this video I am going to discuss integration by trigonometric transformation. In my last videos I have discussed integration by parts method, integration by using standard formulas and integration by partial fraction method. Here I am going to discuss integration by trigonometric transformation. I will take one example to explain the concept. For example, if I want to integrate tan square of x, so here I cannot integrate the function tan square of x as I am not having the direct standard formula for tan square of x. I have the formula for tan of x, but I don't have the formula for tan square of x. So what I do here, I will write this one as secant square x minus 1. I will write tan square x as secant square x minus 1. Now I can integrate this integrand by using formula because I know the integration of secant square x as well as I know the integration of 1. So we are going to solve such example in this video. Now we will take an example. Evaluate integration of sine square x into dx. So let I is equal to integration of sine square x into dx. So here also I am not having the formula for sine square x. I have the formula for sine x. So I will convert this sine square x into linear power. Here the power is 2, linear power, by using a half multiple angle formula. So we know that cos 2x is equal to 1 minus 2 sine square of x. So here I will use this formula. So 2 sine square x becomes 1 minus cos 2x, and 2 sine square x is equal to 1 minus cos 2x upon, sine square x equal to 1 minus cos 2x upon 2. I will replace sine square x by now 1 minus cos 2x upon 2. Therefore, I is equal to, it becomes 1 minus cos 2x upon 2 into dx. So 1 upon 2 is constant here. The remaining is here integration of 1 minus cos 2x into dx. So I is equal to 1 upon 2 integration of, so here we are having two terms. I will integrate the first term 1 with respect to x, that is x minus integration of cos 2x is sine 2x upon 2 plus some integration constant c. Therefore I is equal to x upon 2 minus sine 2x upon 4. I will multiply 1 upon 2 to both the terms plus c. So this is the required answer. I will take one more example. Evaluate integration of cos square of 2x into dx. Solution. Let I is equal to integration of cos square 2x into dx. So in this example also I am having the formula for cos, not cos square. So again I will convert this into linear power by using half multiple angle formula. We know that cos 2x is equal to 2 cos square x minus 1. So this is cos in terms of cos formula. So therefore 2 cos square x equal to 1 plus cos 2x. So cos square x is equal to 1 plus cos 2x upon 2. But here I want cos square of 2x. Here I got cos square of x. Therefore I will multiply 2 and 2 to both sides in angle. So I will write cos square of 2x. Here I will multiply in angle 2. So it becomes 1 remains as it is. In here also I will multiply 2 cos 4x upon 2. So therefore I is equal to 1 plus cos 4x upon 2 into dx. So again 1 upon 2 is constant. Integration of 1 plus cos 4x into dx. So therefore I equal to 1 upon 2 into integration of 1 is x, integration of cos 4x is sine 4x upon 4 plus some integration constant c. Therefore I equal to x upon 2 plus sine 4x upon 8 plus c. This is the required answer. So I'll take one more example. Evaluate integration of sine cube x into dx. So let I is equal to integration of sine cube x into dx. Again here we have sine cube of x. Again I will convert this into linear form. We know that sine 3x is equal to or sine 3 theta equal to 3 sine theta minus, that is 3 sine x minus 4 sine cube x. We have this formula sine 3x equal to 3 sine x minus 4 sine cube x. So therefore 4 sine cube x becomes, I will take this 4 sine cube x to LHS and this sine 3x to RHS. Sine 3 sine x minus sine 3x. So I need here sine cube of x, that is 3 sine x minus sine 3x divided by 4. Therefore I is equal to integration of 3 sine x minus sine 3x upon 4 into dx. So here also 1 upon 4 is constant. The remaining is 3 sine x minus sine 3x into dx. So I equal to, I will write 1 upon 4 as it is. In first term 3 is constant. Integration of sine is minus cos x minus integration of this one is minus cos 3x upon 3 plus some integration constant c. So I is equal to, I will simplify this one, 1 upon 4, this become minus cos 3x minus into minus plus cos 3x upon 3 plus some integration constant c. So therefore finally I is equal to minus 3 cos x upon 4. I will multiply this one upon 4 to both the terms. Cos 3x upon 12 plus c. So this is the required answer. I will take one more example. Evaluate integration of 1 upon sine square x into cos square x dx. Solution: let I is equal to integration 1 upon sine square x into cos square x into dx. Here in denominator I am having two terms, even though here I cannot apply by parts rule. So here I will use trigonometric identities, and first I will simplify this one. So that is I is equal to, so I will write this one as sine square x plus cos square of x. So we know that sine square of x plus cos square of x is equal to 1. So divided by sine square x into cos square of x into dx. I is equal to, now we'll split this one. Sine square x upon sine square x into cos square x plus cos square x upon sine square x into cos square of x into dx. I have split this one into two parts. So therefore I is equal to, sine and sine get cancelled here, so the remaining term is 1 upon cos square of x plus 1 upon sine square of x into dx. So I is equal to 1 upon cos square x is nothing but secant square of x plus 1 upon sine square x is nothing but cosecant square x into dx. So I is equal to, already we are having the formula for secant square x. Integration of secant square x is tan of x, and integration of cosecant square x is minus cot of x plus some integration constant c. So this is the required answer. Evaluate integration of cos 8x into cos 2x into dx. Let I is equal to cos 8x into cos 2x into dx. Here we have product of two trigonometric function. So here I cannot apply by parts method. If I apply by parts method here, I am not going to get the solution, because if I consider the first one as differentiable term and second is integrable term, cos becomes sine and sine becomes cos. The term goes on repeating. So therefore here I cannot apply by parts method. So I will use here formula of trigonometric identities of functions, and I will split this into two terms. So for that, first I will consider this one as some equation number 1. We have formula 2 cos A into cos B, that is cos of A plus B plus cos of A minus B. So I have this formula. I will use this formula here. So for that, what I do here, I will multiply by 2 and divide it by 2. I will multiply this function by 2 and divide by 2. Now I will use this formula. If I compare this one, this becomes A and this becomes b. Therefore I will get I is equal to 1 upon 2 integration of cos a plus b, that is 8x plus 2x, 10x plus cos of a minus b, that is 6x into dx. Therefore I is equal to 1 upon 2 integration of cos 10x is sine 10x upon 10 plus cos 6x is sine 6x upon 6 plus some integration constant c. So therefore I is equal to sine 10x upon 12 plus 2 into 10 is 20 sine 6x upon 12 plus c. So here we have to see, before it was the product of two trigonometric function, so I have used the formula to cos a cos b, and I have converted this into sum of two trigonometric function. So after getting sum of two trigonometric function, I have integrated the first one as well as I have integrated the second one. I will take one more example. Evaluate integration of under square root 1 plus sine 2x into dx. Let I is equal to integration 1 plus sine 2x into dx. This is the function. I cannot apply the formula directly for this function, so I will do some adjustment here. So first I will write this one as sine square x plus cos square x, and I will write sine 2x as 2 sine x into cos x. I am using this formula only to remove this square root sign. Now this becomes a square. It is in the form of a square plus b square plus 2ab. So it becomes sin x plus cos x square into dx. So I is equal to, here square and square root get cancelled, so the remaining is sin x plus cos x into dx. Therefore I is equal to integration of sine is minus cos x plus integration of cos is sine of x plus some integration constant c. Thank you.